Welcome to event 3 in the Encode Polkadot Club series, and today is a technical deep dive. I'm not going to do coding. Well, we're not going to do coding today just because next week there's basically one coding thing you should learn in kind of Polkadot, which is Substrate and how to build Parachains, and that we have a dedicated workshop for next week. So I want to leave a lot of that content. So what I'm going to do today is talk through basically stuff I talked through last week, just in a lot more detail, and give you a complex understanding of the consensus and maybe some of the tokenomics and various other things to do with Polkadot that I think make it stand out and are really cool. So as ever, feel free to put any questions into the chat and I will get to them. Yeah, by the way, Eric, cool thing about Polkadot ambassador stuff, if anyone's looking to be an ambassador, please do reach out to myself or George, and we can kind of fast track you through that process and connect you with the Polkadot team. There is also going to be an event, non-technical involvement in Polkadot in week 6, which is designed for careers and stuff like that. So feel free to join us for that event as well. This is the Polkadot Club series. If you know about Encode, I'll whistle through this stuff. We're a community of developers associated with universities, just in general, great places around the world. This series is a 3-part series of education, which actually this should say, I think we finished education in August, a little bit quicker. Then hackathon, and then accelerator, and it's every Thursday, happening online, recorded and uploaded with slides thereafter, and course material will be shared along with events as well. This is event 3 next week. As I said, intro Substrate, then Parachains. We have 4 of the Parachains coming to give presentations on week 5 in 2 weeks' time. Non-technical involvement in Polkadot week 6, demos of cool stuff within the Polkadot ecosystem week 7, and then a presentation on how Polkadot can affect society, law, finance, business, everything in between in the last week in week 8 before the hackathon gets started. A quick word about, George, I think there's someone kind of got their microphone on, so it might be worth muting them. They sound like Darth Vader, which is slightly off-putting. Cool. So we talked about 2 weeks ago. We'll whistle through this stuff. What is a cryptocurrency? We use this by disambiguating Bitcoin. DOT, the Polkadot currency, is a cryptocurrency, and is a currency that uses cryptography in some way. It actually uses this thing called blockchain, which we care a lot about. And Polkadot is itself a blockchain, and a very cool one at that, which we're going to talk you through the inner details of in this event. A blockchain is like a spreadsheet. It keeps account of everything that has happened, but it's a spreadsheet everyone can edit, and no one has monopoly control over and can overly influence it. Everyone, therefore it is decentralized, everyone can participate, and we can be fairly, we can trust the code that is running, or trust any one individual about the results it produces. And we get these broad features. It's immutable, it can't be changed, it's decentralized, it's trustless, it's incentivized, it's open source, community owned, competitive, and programmable. And we talked about that. If you want to go into the details of that, look back at the YouTube of the first event, Intro to Blockchain in general, where we talked about these features in particular. What is Polkadot? So Polkadot is a scalable blockchain that's made up of specialized blockchains that communicate with each other. In particular, we talked about these things called parachains, which is these kind of mini blockchains is one way of saying it. Because this is a technical event, I want to get a little bit more specific. They are chains that abstract or use Polkadot's pooled security and economic incentives. Basically, its consensus and its token dot in order to kind of abstract away that side of things, so they can just focus on a specialized thing, where be it smart contracts, be it being smart contracts to dApps, be it doing one specific thing. And Polkadot therefore has all these blockchains running in parallel, parachains, parallel chains, which allow transactions to be processed very quickly, but allows lots to be processed at once. So unlike Ethereum, which we've seen as like one kind of lane, one blockchain, Polkadot is effectively made up of lots of mini blockchains, shards, that we call parachains. And they all get kind of linked together in the relay chain. So the relay chain is the main chain of Polkadot, and it's where all transaction information is sent to, and it's where we kind of put all these transactions together and get a kind of a picture of what's going on overall. And this all is adding together means we can have interoperable chains. We have lots of different chains that are specialized working together. But now I want to go into more detail of that. And by the way, Substrate, as you mentioned before, is the kind of framework by which you build these parachains, these kind of different blockchains. And there's a dedicated Substrate workshop next week for learning how to do this. Okay, cool. So now I want to go into more details on this, and we kind of did it in a cursory way last week, but I think we really should go into more detail this week. So the key, why the hell would you want to have, if you are if you're one of these parachains, one of these mini blockchains, why would you want to have this? Well, the reason is you want to pull security, particularly when we talk about security, we mean security from a 51% attack. All the parachains connect to the relay chain by leasing a parachain slot. And they benefit from the economic security provided by the relay chain validators. And what we mean by this is actually economic incentives, is that actually, if everyone is using DOT as their token, then it's very difficult for someone to have 51% of the market cap, enough to kind of take over the network and kind of rewrite the spreadsheet, if we go back to this slide, to have like the only way you can really kind of change the state of affairs is if you are the majority party. But this is extremely difficult to get to if you have a token that is as powerful and has as many holders as DOT. So what effectively they're doing is, in one sense, they're borrowing the Polkadot system to verify transactions, it's consensus. What they're actually doing is saying we're going to use DOT as the economic incentive by which everyone is part of this system. And by being part of one big system that uses DOT as its token, you get a kind of much higher guarantee that there's going to be no 51% attack. That someone, and by a 51% attack, what you mean is that if someone has a majority of the tokens, no one can, you've got no other party that can kind of stop them kind of trying to rewrite the blockchain or change what's happened. Because they are the biggest party, they can do whatever the hell they want. They could slow transactions, they could suddenly take over governance and mint a load of tokens. They could do a real ton of stuff. And they could force through forks that can rewrite the blockchain kind of, or way past transactions have worked. So this is what we kind of care about here. I hope everyone knows the reference, by the way. I'm going to make an offer you can't refuse. That is Marlon Brando playing the Godfather, which is an outstanding film. But what makes the system secure? Well, having more DOT holders means a higher market cap. This is because the more actors involved, the more DOT is bonded and staked. And we'll talk about staking in a minute. And this makes just the network harder to attack if you've got more validators, more staked. And we'll talk about what validators and nominators are, and collators, which we didn't even talk about last week. But for those of you that are kind of talking about, well, what is the, we kind of get into the tokenomics of DOT. And this isn't an argument per se for any short-term kind of pricing, but if you do believe in the vision of Polkadot, there's a very clear kind of security reason and incentive for DOT to accumulate in value as the Polkadot network becomes more used and there's more parachains that themselves have users. Because you've got to use DOT as your fundamental token to do anything, both to do transactions, but also to stake and get the rewards of kind of verifying that stuff's happening, validating it. So this is a very good, this is kind of starts to get into the tokenomics of it, that if you believe the system is strong and the system is big and there'll be lots of parachains, then that money or value should accumulate to DOT. You're going to need more DOT to stake, and you're going to need, it's going to be harder to break the system. So let's talk about consensus. So we didn't really talk about this much last week, and it's a method to agree over the network state. Bitcoin uses something called proof of work. And proof of work is just too energy and expensive. You have to kind of do work, use computing power in order to kind of verify any transactions. And it also has no economic or provable finality, and we'll talk about what provable finality is in a moment. And no effective strategy to resist cartels, which is a separate thing we won't get too deep into today. I want to get to the idea of probabilistic versus provable finality. So now we're getting to the real detail of Polkadot. We're not just saying, oh, it's a sharded blockchain, it allows a lot of specialized blockchain. We'll actually talk about how it improves on something like Bitcoin. So Bitcoin uses something called probabilistic finality. And this means that under some assumptions about the network and participants, if we see a few blocks building on a given block, we can kind of estimate the probability that it's final. So if stuff is happening and more blocks are being built, we kind of estimate, and this block currently is, or the block in question that you're trying to work out how likely it is that it's final was many, many, many blocks ago, and everyone kind of agrees that it's happening. I can kind of make an estimation of how likely it is that this block was right. Which is basically that if there is a block 10 hours ago, and so many blocks have been built on the back of it, then I can be fairly sure the system is robust and the system is going to work. And this is good, but you're like, well, you didn't actually prove that this is final, that everyone agrees on it. You just kind of proved that the system's working. We can kind of improve on this. So you need this thing called provable finality. And Polkadot uses Grandpa, which we'll talk about in a minute. Ethereum uses Casper. And this is the idea that block finality cannot be reverted after some process of Byzantine agreement. Now, Byzantine agreement or Byzantine failure basically says is a problem in computing whereby something can fail, but you might not know it's failed, or it's difficult to work out it's failed because lots of different actors are kind of reporting different things. You have no way of proving it's actually failed. And this is a problem because it might be in the interest of some people to say that the system is working when the system is not working. So we need some way of proving it, that the system, that this kind of everything is working correctly, not just by saying, well, the system looked like it's working correctly, therefore it must be working correctly. You can see why this could fall apart. And we have these two things called Grandpa and Babe, and they are two mnemonics. I swear to God, they just like invented the mnemonics after they invented they're not mnemonics, sorry, they're not, that would be terrible, they're acronyms. So Grandpa means go space recursive ancestor derived from prefix agreement. I mean, what the hell does that mean? And Babe means blind assignment for blockchain extension, which makes more sense. What we get is this thing called hybrid consensus, which you can't really see. You've got the old what the hell is this elephant penguin meme there, but luckily Polkadot's consensus is not so abhorrent. Basically what they do is, rather than we won't get necessarily into too much detail here, but to try and prove that the blockchain is final, that we can agree that this is the state of affairs, it's right, it splits up the finality gadget, or the way finality works. And instead of this, you get all the benefits of probabilistic of finality, which is you can always produce new blocks. The system doesn't just break down, but you get provable finality. You can get a universal agreement that this is actually what's happened and we don't need to go back, because that'd be a disaster. Imagine like having to go back and reverse transactions. This is not a blockchain anymore. So Babe that's Babe Ruth on the right. It's not based on him. Is a block production mechanism that runs between the validator nodes and determines the author of new blocks. It's comparable as an algorithm to Ouroboros, with some key differences in chain selection and slot time adjustments. What it does is it assigns block production slots to validators according to their stake and using some randomness function. So first of all, it assigns kind of blocks to kind of validators fairly randomly. And then the validators in Polkadot participate in a lottery in every slot that will tell them whether or not they're the block producer. The slots are discrete units of time. The slot is about 6 seconds, and multiple validators could be candidates for the same slot. Other times the slot could be empty, resulting in inconsistent block time. Now, Grandpa is the different bit. So Grandpa is the finality gadget that's implemented for the Polkadot relay chain, i.e. the Polkadot main chain that kind of verifies all the transactions. And now we get a little bit technical here. So it works in a partially synchronous network model as long as 2/3 of nodes are honest and can cope with one out of 5 Byzantine nodes in asynchronous settings. So 1 out of 5 kind of nodes reporting kind of falsely that the system's working when it's not. It reaches agreements on chain rather than blocks, speeding up the finalization process even after long-term network partitioning or the networking fails. In other words, as soon as more than 2/3 of validators attest to a chain containing a certain blocks, all blocks leading up to that one are finalized as one. So it relies on the validators basically to attest that the chain is working, rather than looking at the chain itself and saying, well, stuff has passed, therefore it must be working. So it's a slightly different approach. So that Grandpa, despite its kind of complicated acronym, basically just says this: we're going to use validators to attest that the chain is right and final and what they say, rather than just using kind of a probabilistic model based on, oh, well, the system is working, therefore it's working. And then we need to get to the idea of validators. So you have 3 different types of kind of user in the Polkadot network. You have nominators, validators, and collators. And after I've done the kind of slide section of this presentation, I'm actually going to go on to Polkadot.js and show you how you can become a nominator or validator, because I think it's quite cool and I think you should know it. And this is now we can start getting to some of the tokenomic side of this. So nominators secure the relay chain by selecting good validators, and you stake some DOT, and you pick good validators, and if they are good, you get some of their rewards, and if they're bad, you get slashed, or you kind of get punished. Validators secure DOT, and they validate proofs from collators, and they participate in consensus, part of the kind of grand path consensus, to verify that things look right, and yeah. And collators maintain parachains by collecting the transactions in the parachains and then sending them to the relay chain. So basically, they are the connector between the parachains and the relay chain. Going further, if you want to earn DOT, like being a nominator is like the best way to be, because it's fairly, you don't have to do any actual work, and you benefit from some of the rewards of the kind of being a validator as well. And you nominate by staking and locking DOTs, and if the validators misbehave, you kind of lose, and if they follow the rules, you get a share of their kind of rewards. So basically, you're staking money as a bet on kind of validators in order to kind of trying to figure out if they are, in order to make money, but also as a result of kind of, you don't want to lose money, and what the system gets is better validators. Validators are the people who bet on, kind of stake money that they're going to perform, and that makes the system kind of altogether more secure in an economic incentive way. Yeah, this is a good reason why we'll go into the tokenomics of DOT, but this is kind of a good mechanism as part of it. Validators perform two functions. They verify the information contained in a set of parablocks is valid, such as the identities of the transacting parties, the subject matter, and they participate in the consensus mechanism, produce relay blocks based on validity from other validity statements from other validators. In instances of non-compliance with the consensus algorithms, this results you can be removed, your DOT can be slashed, it can be taken away, and good performance is rewarded. Point of the validator is to both check transactions and check that other kind of validators are correct. And the sum result of this is if you have enough validators, and there's quite a lot of validators, I think it's almost 1,000. If you have a lot of validators and they're all checking each other's work and they're all kind of incentivized to get results, you want to, as long as you are in the majority that kind of thinks that the system is working well, then you will, as long as there is a majority of people who are good actors, the system should work completely well. And a majority, I mean a supermajority, which is 2/3, which if we go back to the kind of ground plan explanation, is you need 2/3 to kind of, for the kind of the blocks to be final, for us to kind of think the system is working perfectly well. And it's in their interest to do so, because you would have to convince a lot of validators to kind of act incorrectly, at least 1/3, in order to both keep getting rewards and not be caught for kind of being a bad actor, and for not verifying that stuff is kind of going well. Which, to do that, you'd have to stake a lot of DOT, and you'd have to have a lot of the nominators behind you, which because there are so many DOT holders, this becomes extremely difficult to do, and DOT is worth quite a lot of money. Again, extremely different to do, so it's not worth risking being a bad actor. So this is, again, one reason why the DOT has economic incentives that skew the system, and why lots of different parachains would want to use DOT. I'm going to take a drink now just because my throat has gone. And we'll take a break to answer questions in a moment. And last but not least, collators maintain parachains. I'm going to have some more water, sorry. It's a very hot day and I'm losing my voice. Oh. Cool. So collators maintain parachains by collecting parachain transactions from users and producing staked transaction proofs of relay chain validators. In other words, they maintain parachains by aggregating transactions into block candidates and producing state transition proofs of validators based on these blocks. You basically cannot continue to build blocks until the block candidate they proposed has been validated. And they have to maintain a full node on both the relay chain and the parachain, meaning they retain all necessary information to be able to both author blocks and execute transactions. So again, they're just a middleman, and they get incentives for doing so. I'm going to stop there and just take some questions, because I see 37 in chat. We will. Let's go up. I don't know how many dot you need to get a Parachain slot, but it will be on the Polkadot.js and the Polkadot wiki. How do Parachains auctions work? How do they go on Kusama? We can get into that later. I haven't got a specific thing to cover here. I'm interested in provoke punishment attack. A lot of these POS have punishment disconnection. Okay, we can get into that. How is MEV in Polkadot? I don't actually know. Can you talk a bit about the transaction point of Polkadot, how it differs from the transaction point of Ethereum, especially with MEV being a big problem? Okay, we can come to that towards the end. I guess that is similar to the how many blocks? I think it's, I don't know exactly, but it doesn't take that long. We can look at it on the Polkadot.js a bit later. How can you confirm validators are acting honestly? So the point is you don't need to confirm. You just try and design a system with a strong enough token that it's in everyone's interest to act well. And it would take a hell of a lot of dots and a hell of a lot of, you've got to think, why is it in someone's interest to act dishonestly? Because like, to what end is that? And B, you've got to create strong incentives for people to act well. And again, if lots of validators say you're not acting well, like you're screwed, so you need to control a lot of validators to probably make it worthwhile to control the system, and that would be extremely expensive to do so. Sorry, I can remove the GIFs next time. Yes, relay chain equals canonical chain. Why is onboarding 28 days? Probably to stop people unbonding, and also so that it's a big commitment when you have to stake. Yeah, we'll be on YouTube. Slashing. So we're looking slashing a bit. Anyone could be a collator. I'm confused about the structure of a shard as parachain. Would that make it its own sub-blockchain that the relay chain would be the main? Yes, exactly, Joe. So the relay chain is like the main blockchain, or the main kind of the main thing confirming everything's happened. But it's not really a blockchain in itself. It's kind of just a consensus mechanism. We're not taking audio questions, but feel free to put it in chat. Would they be slashed if they lost plaids during, say, a storm? I think they probably would temporarily, but the penalties wouldn't be that bad. I think it'd be like 0.1%. How does one become a collator? I'll show you. How is that possible to apparently work as a bridge between Ethereum and Polkadot? What do you mean specifically? Maybe put that in chat. What are some of the main differences between collator and validator? Well, validator is confirming all transactions on the network, whereas collator is just effectively bringing transactions. A, it's confirming transactions that good on the parachain, and B, taking the transactions to the validator. So it's like a postman, effectively, is the way to think of it. Whereas the validator is the post office. They're checking or maybe that's a bad example, but the validator is just checking all the transactions are right and look correct. Do parachains have to validate themselves? Some, but again, it's the collator's job to make sure it looks good on the first instance, and the validator's job to make sure it all looks good when put together. Cool. We'll take a few more questions later, and a few things I've noted to come back to as well. Cool. So that's kind of collating and nominating, validating. We'll go and look at the Polkadot.js in a bit to kind of look at that. I don't have a slide on it, but I did want to talk about tokenomics. Again, I'm not a, I don't have any particular view. I'm a fairly risk neutral individual as things go, but a little bit about how the, actually, do I have maybe we get on to on staking. A little bit about how staking works. So in the Polkadot network, you have kind of two. Okay, so if you want to be a nominator or a validator, you have to stake DOT to do so. I can't remember the exact one, but we'll have a look at it later. and you get rewards for doing this. And the rewards are better, obviously, as the network is busier. I believe the most amount of new DOT that can produce a year is 10%. And pretty much the only way to kind of cut this DOT, to slash this DOT, is basically any unspent so, and if on some cases, if there's kind of lots of validators, lots of nominators, some of the kind of unallocated rewards from staking goes to the treasury, and the treasury actually spends money on programs like this and for giving grants out and stuff. And if it doesn't spend all of its money on a given quarter, which is period, which I believe is every 24 working days, this money gets slashed, either in its entirety or some of it, depending on how big the amount is. That's a fairly limited mechanism to get rid of DOT and kind of reduce the supply of DOT. There's no fixed supply of DOT. So there's always you should assume about 10% inflation per year. And obviously staked DOT is locked and you can't unlock it for 28 days, but it's not permanently locked. So there is a natural inflation, but the maths you should do if you're a long-term holder and you are interested in this sort of things, and there's very reasons not to be interested in this sort of stuff, is if you think that the demand will increase greater or equal to 10% every year, then you should hold DOT. And if you don't think the demand will increase greater than equal to 10%, then you shouldn't hold DOT. Again, you have to make also some extra assumption about what people will do with the extra supply of their DOT. The kind of rewards of staking of their DOT, whether they're going. I think you should reasonably assume everyone's going to sell it immediately, but people might want to restake it, and so there is a certain velocity of the money to be borne in mind. But if you think demand for DOT because of things Parachains are doing, because of how secure the system is and the robust, and obviously the more DOT holders there are, the more robust the system becomes, and therefore because you've got this framework for blockchains to build on top of it through Parachains, or you've got this kind of a natural way for demand to increase, then this makes DOT a good bet. Now clearly there are a lot of short-term price concerns that affect the price of DOT over and above what is happening to the basic supply and demand. But in terms of the basic tokenomics, we know DOT is used as the kind of currency for transactions and is the kind of base currency on all the parachains, and it's used to kind of secure the system and incentivize people to participate in consensus and be a validator or be a nominator. Then if you believe that the system's good, I think people will want to build on it. People will use applications built on Parachains, and I can work out this increase in demand year on year will be more than 10%, then DOT should be a good bet, all price considerations aside. I will take questions on that just because that's yeah, okay, you can do some basic stuff on APY as well, but yeah, so you can make some also money. Yeah, you can make some money back by staking as well, rather than, I'm assuming you're actually not staking, just holding it in your wallets. Would it be possible to smoke on running with the executed pace? Right, executed pace on a DOT wallet. Yeah, don't see why it wouldn't be possible. You would probably need to use something like Moonbeam that runs on Ethereum or runs is compatible. I'm losing my voice so much. Sorry, guys. Corinne will take your question as well in a minute. Yeah, it would be possible is the answer. And we'll get into that, sort of into the coding stuff next week. How do you prevent double spend? Well, the validators are checking that the transactions are consistent. So whilst you can have transactions kind of work in parallel, then when the transactions will come back together, you can kind of see the relay chain is kind of looking at them as like one big sequence of time. So they will look at one given time at what everyone has and go like, oh, well, like George has clearly paid twice here and tries to do it in the same block or the same slot, which is 6 seconds. Then this is wrong. Like flag this as like he's double spent. But it'd be very difficult to double spend given, like, think how that would literally work. Like how would that work? you basically have to get lots of nodes, lots of validators trying to report that George is double spent, or say that try and hide the fact George is double spent when she had double spent. But again, you need a lot of validators, therefore a lot of dot to be able to achieve this. I don't actually know the number of collators, but it's on Polkadot.js, which we'll go to. Cool. Julian is dropping some stats in the old Zoom. Okay, cool. So we'll come on. We're going to go through Polkadot.js in a bit, but I've got a few more general slides I want to go through to some cool stuff. So Polkadot uses referendums to do its governance. This is usually weighted by the stake, number of votes you have to make a decision. Each referendum has a specific proposal associated with it, which takes the form of a privileged function call, including, this is cool, you can upgrade the code through the powerful call, which is called setcode, which means that you can change the entire code without having to do a hard fork, which is basically say, copy and paste the code and start again. Which is, as we've seen with things like Ethereum, it's kind of hard to do, and you sometimes get things like Ethereum Classic, which are complete forks of the code, because people don't agree on the new kind of the new code base. So I think that's quite a cool thing to do, and it all runs based on referendums, based on how much kind of dot you have, and anyone can participate in these. Proposals, obviously not this type of proposal, can be started in one of several ways. There's public ones, you can submit them to council, there's emergency ones, various different kind of things at very different levels. And you've also got treasury proposals, again, which Encode went through when we got funding for this program. And we went through like a full council vote and a Polkadot treasury vote, and everyone voted, and we had to stake money to make the vote. So you can't just put random votes up. And I think there's some quorum as well. Quorum means minimum attendance, so that you can't just like create a vote in the middle of the night, like vote on it yourself using your dot and like get loads of money from the treasury. That would be a disaster. So there is quorums as well. I can't remember what the exact quorum is, but there is one. Another cool thing that in Polkadot, which some of you haven't known, as we talked about Babe earlier, you need kind of randomness to be able to assign, because you want to randomly assign who gets rewards at any time. And randomness is important, and it's hard for computers to do randomness, as some of you may know, because computers are deterministic. Computers, like, they work by a process that is code-based and software and hardware-based. And if you know that, you can kind of always find the path that a particular blockchain has taken or computer has taken to develop the random number. So we have to use these things called variable random functions, which we'll go through now, that are mathematical operations that take some input and produce a random number along with the proof that this is random. So that if anyone wants to challenge that, they can kind of see this. And this is a terrible slide because no one can actually see it, but I can see it, so I can read it. And so it takes slots, which we talked about, kind of that are 6 seconds long, and each slot contains a block, might not. And slots make up these things called epochs on Polkadot, and 2400 slots makes one epoch. And so an epoch's about 4 hours long. So every slot, each validator rolls a dice. They execute the function, the VRF, that takes as an input the following. So a secret key, which is a key made specifically for these die rolls, the epoch randomness value, which is the hash of the VRF values from the blocks in the epoch before last. So past randomness affects current randomness, and the slot number. And it takes these inputs, and we get, as a result, a random number and a proof that the random number has been generated correctly. So the method by which we did it. And that's how you do randomness. Without going getting even further into that, this is how you do randomness in Polkadot, which again is very important if you're going to randomly assign blocks to people and randomly assign rewards, which is just a method that's chosen by most chains to do rewards that not everyone gets a reward every one time. Cool. And last thing I wanted to say is that the Polkadot network, you have the Canary network, which is Kusama, testnet, which is West End, which is if you want to do stuff on Polkadot. We're not doing coding stuff today. If you're interested in WebAssembly, then you want to do kind of smart contract enabled stuff, you use Canvas, and use Rococo for Parachains if you want to do a testnet there, building a Parachain. That's the first thing I wanted to mention today. And we're now going to move on to the second half, a little bit, about 40 minutes in or so. Which is Polkadot.js, and let me find, and we'll talk through setting up an identity and how you become a validator and a collator, etc. I'll just take a cursory look at the questions. I don't know what you're talking about, Clifton. Okay, nothing to much to worry about there. Cool. So that's going to load now. So I'm going to do this in real time, which is probably going to be a disaster. I knew this would be a disaster. Ah, here we go. Okay, cool. So I think we briefly talked about last time how you would create an account. I think I've got my Encode Ledger account here somewhere. Yeah. So to create an account is actually very simple. You just go add account and it will talk you through. You save in the mnemonic and you call it a name, give it a password, and it's accessible every time. You kind of log in, particularly through this browser, but also you can use it for any browser. You can also add via Ledger, so you can create an account on Ledger under Polkadot and add it this way. So now once you've kind of got an account, you can send dot through this account to any address. You can delegate your votes. You do many different things. I will keep chat open as I talk. Okay, no. But let's say we wanted to get into kind of staking. So this will take a while to load because Polkadot.js is slow. Cool. So you can see there are 297 validators. And each of these validators you can see all the addresses. They're all listed publicly. See if everything loads. Oh, that's not good. No. Clearly, the Polkadot network is busy. / my laptop is like red hot right now. Come on. Cool. And you can see how many blocks they produced. You can send them a message. You can see who's nominating them. And we're going to get this. Oh, I'm sorry my laptop's so slow, everyone. I truly do think it's actually Polkadot. But also my laptop is historically very slow. What is going on? No, don't worry. One more go. I might get my colleague George to share his screen otherwise. The site is actually very slow, always in my experience. I should have just pre-recorded it, but I wanted to do a live thing. Woe is me. Might close Windows. Anyway, I will talk through so we can see how long an epoch is. So you got. I want nominators to thing because there's a chance for you still to become a nominator. There is a limit. I can't remember where the limit is set from, but I believe at the moment there's about 20,000 nominators and they're not all active. And so you can become a nominator, and you do that by going to account actions if it would load. George, can you try and load it up on your computer and see if it works?
Yeah, it's being slow for me as well. Still
Okay.
loading.
All right. That's annoying though. I wanted to show you guys stuff. We'll get one more go. Anyway, I can show you this stuff while it's loading. So if you do want to become a nominator, you go to account actions, you put your stake in, and you can start earning rewards. You do need to identify validators you trust, but there's various articles on how you should do that online, or you can message me if you're unsure. Governance, I'm actually going to do wait. Governance, this is where you can kind of see all the proposals, all the democracy, and you can see all the slashing on here as well. You can see all the validator stats. Polkadot.js is your kind of place. I wish you could show you, but it's just not working. Polkadot.js is the place to kind of go to see everything and become a nominator, become a validator, etc. So that has ruined the second half of my talk because I very much wanted to show everyone the Polkadot.js, but I'm going to take questions and see if it's going to load for me privately. So I'll take more questions. So what are my thoughts on stake via an exchange, the benefits of moving my dots to dot? No, there's also there's a reason why you would do it on platforms like exchanges, because this is just staking for the benefits of validating and nominating, whereas you can stake for the benefits of like not stake as in staking, but stake as in kind of getting interest for people kind of borrowing your dot. So there's reasons to not just use Polkadot.js or etc. So I think that if you can get, again, if you're a holder, long-term holder, and you want some extra interest on top of that kind of bet, that I think staking is kind of essential, and wherever you can get the best interest rate. I'm not sure where you can do it. I think it's cool being a nominator just because you become quite become quite in depth with how the system works, and maybe you can spot certain edges or things where I don't know things are missing, or maybe you could become an amazing validator and get fantastic rewards and have more nominators. Because you want to be a validator that has the kind of as many nominators as possible, because people shows people are trusting you. So yeah, yeah, no, I love the Polkadot.js app. It's very nice. I actually don't know the minimum number needed. I'm sure it's kind of on. I'm sure it's on there. I haven't checked it kind of recently. It's apparently it's 40. So 40 dot. That's not too expensive. What's that? About $500. Now's a good time to do it. So why not do it and start earning some reputation if you're interested in Polkadot. And Polkadot.js again is very straightforward to use. Mine has also started working as well. I'm not going to try to share my screen because it will break. But if you go, if you've got Polkadot.js in front of you, so I would go to, so if you go to network, oh no, it's going to slow down terribly. That's all right. Then I want to take Giles' question. 2 questions. So Polkadot is used transactionally. What coins that load to yours from Parachains? Yes, dot would be used when using lifting through. Sometimes these Parachains also have their own token, but they kind of at least the main token from a security perspective would be dot. Some of them will use dot for the actual Parachain, some of them won't. Heard Harmony dot is that dot is hence scalability issues with cross-chain relay-chain finality. Any comments on this? I don't know actually, but I imagine it's quite hard problem to solve because yeah, it depends what you mean specifically by cross-chain relay finality. Because the parachain finality is absolutely fine. That's the whole point of Polkadot. But the kind of yeah, I didn't quite know what you mean. Cool. Let's keep taking questions. How do I do my due diligence on validators? Well, all the information is public. So just go online to Polkadot.js, look at what they've done, look at how many transactions they verified, see if their identity is online, associate your identity with try and like look up, like, do they look legit? Are they a fund? Are they like an individual? Like all of the above. So this is how I would do it, but I think you'd be fairly confident if someone's verified a lot of transactions that they are, yeah, a good person. I'm not actually that familiar. A lot of questions about Polkadot auctions. I'm not actually that familiar. I believe you're talking about the Polkadot auctions associated with Parachains yeah, I don't know when the first one is. These are slots for specifically for Parachains to be deployed on the network. I don't know when they are. I think they're all supposed to be now, I believe. This is the current phase, but I would check out Polkadot, Twitter and stuff for when the specific ones are coming out. What else? What reward do you get from being a validator? I'm trying to think the exact rewards. I believe it's something like, let me see. Yeah, let me see. I don't know exactly, to be honest, but I'm sure it's all online somewhere. Since Ethereum is Turing complete, could it theoretically do everything Polkadot could do? Well, no, because you can't build. It's like a very different like vision. It's like Ethereum is a complete blockchain, has consensus, has security. Whereas Polkadot is saying Polkadot like you can't really build. You can, but you can't really build smart contracts on top of Polkadot itself. You have to do it via a parachain. So it's like saying. It's like this. Has anyone ever played Google Stadia versus PS5? So PS5, you have the console in front of you, you have the hardware, you can run the game yourself. Stadia, what you do is you connect to a cloud, and the game runs in Google servers, and the imagery of the game kind of is just streamed to your device. So actually, what you're watching is you're pressing the joystick, which is pinging a server, which then does the action for you and sends it back to you on the video. You're basically controlling a server that's miles away and seeing the results. And that's basically what Polkadot is. It's Google Stadia versus PS5. No comments about quality. I put that. So in kind of this, the parachains are like your device you have in your hand and do the stuff and run and kind of you play how you interact with the games. But actually, it's all running really very much not a server, but it's running somewhere else. It's abstracted away so that you only focus on the kind of the experience itself, whereas in Ethereum, like everything is in front of you. It's there. So that's a very labored example, but the way to say it is that they're very different. Polkadot is like the engine, and then you can build stuff on top using the engine. Ethereum is just everything in one, and the reason why you would use Polkadot over something like Ethereum is then Polkadot allows for more specialized blockchains that do specific stuff that all rely on one kind of inner system. Ethereum could theoretically run on Polkadot. Can you recognize any dApps like to test just for fun? So the place to go is a place called Poker Project. If you want to look at some dApps, we're going to have 2 weeks of project demonstrations as well for you to look at. Oh no, I've just managed to that was impressive. Yeah, but we'll have 2 weeks of project demonstrations as well for you to see cool stuff. Are there any plans to create a London Falcon to burn some dot pressure action reduce? Not that I know of. I don't really see it as a huge problem. Like, to throw the question back to you, Joe, why do you care about that? Because if you care about it, 'cause you're like, I'm worried about token price, like, I don't think your whole theory on kind of token price should be based on like this slight inflation rate. Yeah. Oh, George says his thing has loaded. So George, you want to share your screen and I'll talk through it?
I just closed it because I thought you were let me.
Oh, don't worry. That's a disappointment. Yeah, I'm gonna regret the Stadia versus PS5 thing. I just meant that with with Polkadot, you have these blockchains that abstract away the consensus layer and the security by saying we're just gonna use the dot token and we're gonna send everything to one big consensus system rather than running our own. Whereas Ethereum has its own in one, But the result is Polkadot, you have something that can run lots of different kind of blockchains simultaneously. It's just much bigger. It can run many more transactions. Versus Ethereum per se. Will you be introducing PokerSwap? Maybe from week 8. My throat is dying. Is the IKEA of blockchain? Yeah, I guess so. But IKEA is not a framework either. It's just cool furniture. Good. What have I missed? Any questions? I'm sorry I can't show you Polkadot.js. That was a key part of my presentation, but I will put some stuff online on the Medium afterwards. Any other questions that I've missed? So next week, do join us for the introduction to Substrate. So I was actually looking to the treasury, actually, because again, I remember when Julian, I remember when we were going through the process, I actually was looking, I needed to really understand deeply what was happening. And it is my understanding that, I'm trying to see now, I'm just checking now. Yeah, I believe the burn, if they don't spend the money in a given quarter, a certain amount is burnt. I think that's only 1% at the moment. Yeah. So if you go to here, so it's actually a very low burn. So money kind of from slashing goes to treasury, and if after 24 days it doesn't spend all this money, there's 1% of those funds get kind of burnt. But this is like very, very tiny. Like extremely tiny. Well, there's 4 places you get money: it's slashing, transaction fees, staking inefficiency, and and power threads, which you haven't talked about. So basically the end result is maybe at most 1% gets burnt every 24 days. Now, clearly, like 1% is like quite a lot, like every 24 days, like this. But in aggregates, I don't think it's that big a burn, really. I really don't think it's that big a burn. But interestingly, just this is kind of anecdotal information. This is just anecdotal information. We were very much pushed to put our funding request in by the end of the 24-day period. So it's clear that they do care about making sure the money is spent. So that obviously it is quite a big threat, but not a huge threat. I don't know about MAV on Polkadot, unfortunately. I imagine similar issues, because basically MAV is people front running transactions that they see in the memory. That basically transactions that are about to be validated, people see them and they think, oh, that's a good transaction, that's going to make this trader going to make a lot of money, and they preempt it, they front run. I don't see why that wouldn't also be an issue in Polkadot. I don't understand technically why it wouldn't, but yeah, I think it's probably still an issue. There's not as much activity on Polkadot, so I imagine people don't do it as much, but I imagine that might be a bit of an issue. So boss, let me go back to your question. I need to find it now. Could you repaste your question?
I've repasted it at the bottom.
So basically what you're talking about, disconnecting from networks. That's a good point. I think I read something. Give me a second. I need to look at the validator rules. By the way, there's some fantastic stuff in the the wiki about how to become a validator and how to run a node. I believe you have to be on the whole time. /Babe also. I think Babe, that's also why you've got Babe. So to allocate who's going to be validating stuff. And I imagine that will check if something's online to begin with and not allocate to someone who's not online. So that's one good way of doing it. I don't actually validate. I saw it earlier. Yeah, okay, they do get punished. I don't know how exactly much they get punished, but I think they just get punished immediately just by not being active. There must be some checks. Slash the other validators do checks on each other. There's some very good stuff here if you want to read more on it. Yeah, I believe it'll be the other validators punishing validators. Cool. Any other questions from anyone? Cool. We reached 6:30. Thank you everyone for coming. This will go up on YouTube and Medium. And thank you very much for joining us. If you have any private questions, please feel free to Kusama will always be a Canary, just a test place. A place tests go first. Clifton. So please feel free to email myself or George. My email I'll just quickly put into chat. But you can find us also on the Discord. Thank you very much for everyone joining. Next week is the Substrate workshop. More coding-y, more technical. I've tried to keep everything fairly open and easy for everyone to kind of get their teeth into. And this one was a lot deeper than the kind of cursory starter guide we did last week. But thank you for everyone for joining us. I greatly enjoyed this. Fantastic questions. George has put the kind of the Eventbrite in chat, and we'll hopefully see you all next Thursday. Thank you very much for attending, and have a good rest of the day wherever you are.